Hello, I'm here again. It's a new day. It's beautiful to see you, beautiful people, and I'm glad you're back to my channel. My name is Rahma from Chemistry Extensive, and if you're new to my channel, please subscribe to my channel. And to my previous subscriber, you are mostly welcome. Thank you, and please do give the video thumbs up, share it to your friends, please give a good comment, and if you need some topic you want me to discuss, please feel free to talk about it. And thank you. Today we are going to talk about the calculation of wavelength and frequency, the relationship between wavelength and frequency. Today, we are going to bring those calculations down. Thank you. Let's go there.
Greetings to you, everyone. Today, we'll be discussing calculation on frequency and wavelength. In our previous class, we discussed electromagnetic radiation such as visible light that is treated as a wave phenomenon characterized by wavelength or frequency. We also discussed wavelength as the distance between adjacent peak or trough in an electromagnetic region, and will be designated in meter or nanometer, centimeter or micrometer. We also talk about frequency as the number of wave cycles that travel across a fixed point per unit of time, and is usually given in cycles per second or hertz. The visible wavelength cover a range from 400 to 800 nanometers. And also we discussed that the frequency can also be defined as number of oscillation per second. So the relationship between the frequency and wavelength. The longer wavelength we have, the shorter or the lower frequency we have. While with the shorter wavelength we have, we are going to have high frequency. So the frequency is inversely proportional to the wavelength. This leads us to the equation of C equal to V over lambda, where V is represented frequency in hertz and or per second, the C representing the speed of light in meter per second, and the lambda representing the wavelength in meter, centimeter, micrometer or nanometer. And this is represented with the equation of V equal to C over lambda. And we also discussed that the longest visible wavelength has red, and the shortest one has the violet. Also, the color of the spectrum, the common color of the spectrum in order of decreasing wavelength can be represented by the dynamic of Roy GB, which R is representing the red color, O representing orange, Y representing yellow, the G representing green, B representing blue, I representing indigo, and V for violet. And all these representing the wavelength of the visible spectrum in electrospectroscopy, in UVV spectroscopy. So this leads us to the question that we wonder what happened to frequency when wavelength, what happened to wavelength as the frequency increases. This is from the equation, the lambda, when wavelength is inversely proportional to the frequency. Wavelength is inversely proportional to the frequency. That is, when the frequency increases, the wavelength decreases, and when the frequency decreases, wavelength increases, vice versa. Let's quickly do some calculation. This calculation said, calculate the wavelength of a photon that have a frequency of 2.7 times 10 raised to the power 11 Hz. Can you do it? Using the formula of lambda equals to c over v, which is speed of light over frequency. Using this value, can you quickly do it? Remember that the speed of light is a constant, which is given as 3 times 10 raised to the power 8 meter per second. I hope you tried. Okay, let's continue and see if you get the answer. The frequency that is given from this question is 2.7 times 10 raised to the power 11 Hz. And the wavelength, we are supposed to calculate for it. Using this equation, lambda equal to speed of light over frequency, 3 times 10 raised to the power 8 meter per second over 2.7 times 10 raised to the power 11 per second. We calculate this and we have 3 times 10 raised to the power 3 times 10 raised to the power 8 minus 11 tends to raised to the power 8 raised to the power minus 11. This over 2.7. This is so because when a raised to the power is moving from the division line to the upper division side, is going to carry a negative sign. And as we can see, the second cancels second, and then we have the final answer is 1.11 times 10 raised to the power minus 3 per meter. And the answer can be left like this. This meter is acceptable as a standard for lambda, or if according to what is needed, you can also convert from meter to centimeter. Meter, we can always convert from 1 meter to micrometer. Converting meter to micrometer, we can say 1 micrometer is equal to 10 times 10 raised to power minus 6. 1 micrometer is equal to 10 raised to power minus 6. And also 1 meter is equal to 10 raised to power 6 micrometer. Micrometer is less than meter, and meter is more than micrometer, as you can see here. We are converting to micrometer, therefore the micrometer will be up here, as we can see. So 1.11 times 10 raised to power minus 3, that is gotten from here in meter, multiplied by 1 micrometer over 10 raised to power minus 6 meter. So the meter cancel meter, and we are left with 1.1 times 10 raised to power minus 3 times 10 raised to power minus 6, and times 10 raised to power 6, as we can see here. And the final answer is equal to 1.11 times 10 raised to power minus 3 micrometer, because our 6 has positive, so this is going to carry a positive sign. 1.11 times 10 raised to power 3 micrometer, so or 1110 micrometer. Or we can also convert it by saying if 1 micrometer, if 1 meter is equal to 10 raised to power 6 micrometer, what will be the value of 1.11 times 10 raised to power minus 3 meter in micrometer? By cross multiplying the equation, we have 10 raised to power 2.6 times, by cross multiplying like this, 10 raised to power 6 times 1.1 times 10 raised to power minus 3 over 1 meter. So the meter cancel meter, then we will be left with 1.1 times 10 raised to power 3 micrometer, or 1110 micrometer. So let's quickly calculate question number 2. What is the frequency of a photon that has a wavelength of 2.6 times 10 raised to power minus 9 meter? V equal to C over lambda, that is the frequency equal to speed of light over lambda. The frequency, the wavelength, and the speed of light, they are spelled out. The speed of light is given as t times 10 raised to power 8 meter per second, and the lambda is given as 2.6 times 10 raised to power minus 9. So using this calculation, we substitute V times 10 raised to power 8 meter per second over 2.6 times 10 raised to power minus 90, that is given from the question in meter. The meter cancel meter, and the frequency equal to 3 times 3 over 2.6 times 10 raised to power 8 minus 9 minus into bracket minus 9. As we can see here, when 9 cross the division side, it tends to carry a negative side. It tends to carry a negative sign, and is already having a negative sign. So you're going to bracket the minus 9. So this will give us 1.154 times 10 raised to power 8 minus 10 raised to power 8 plus 9, and this is going to give us 1.154 times 10 raised to power 17 per second, or 1.154 times 10 raised to power 17 hertz. So let's quickly have one more calculation. What is the wavelength of a photon that has a frequency of 82 megahertz? From this question, we can see that the frequency that is given to us is in megahertz. Therefore, we need to convert the megahertz to hertz. Using the formula lambda equal to C over V, that is the wavelength over speed of light over frequency, where the lambda and where the wavelength is given, the speed of light is given, and the frequency is given. This, to convert the megahertz to hertz, 1 megahertz is equal to 10 raised to power 6 hertz. Therefore, 82 megahertz over 1 times 10 raised to power 6 hertz will give over 1 megahertz. Because we are converting to hertz, is going to be on top. So, or we can convert it as, if 1 megahertz equal to 10 raised to power 6 hertz, then what will be the value of 82 megahertz in hertz? Therefore, we need to cross multiply. Cross multiplying, we have x megahertz equal to 82 megahertz multiply with 10 raised to power 6 hertz over 1 megahertz. Megahertz cancel megahertz. We have 82 times 10 raised to power 6 hertz. So therefore, we are going to use that to continue with our calculation to get wavelength that we enhance from the question. So 3 times 10 raised to power 8 meter per second over 82 times 10 raised to the power 6 per second. Please feel free to pause the video for better calculation. Therefore, 3 over, and before we go into that, 82 times 10 raised to the power 6 hours is equal to, is as the same as 82 times 10 raised to the power 6 per second for frequency. So either hours or per second can be used as a unit for frequency. And also we need to take in note that the meter per second is the same thing as this. So let's now go back to our calculation. 3 over 82 times 10 raised to power 8 minus 6, because the 6 is crossing the division side, is carrying the negative sign, and this answer is in meter. So the final answer is 0.0366 times 10 raised to power 2 meter for the wavelength. So therefore the wavelength is 3.66 times 10 raised to power minus 2 times 10 raised to power 2. How do we come about minus 2? Because we are converting it to the standard form, which we are going to move 1 and 2. So moving the point from 1 to, we have 10 raised to power minus 2 because we are moving from the negative side. So times 10 raised to power 2 we have here, and the meter. The negative 10 raised to power minus 2 and the 10 raised to power 2 cancel each other. Therefore, we have our final answer as 3.66. 3.66. This is a point sign here. This here is a point sign. 3.66 meter. I hope you enjoyed the video. Thank you for watching up to this level. Don't forget to subscribe. Don't forget to share with your friend. Let the video get viral.
Thank you for watching to the end. I hope you enjoyed the video. I hope to see you in the next one. Bye.